In this video, we're going to show you two ways of producing a graphic for numerical data. The first one is called histogram, and the second one is called box plot. So let's get to it. The first graph that I'm going to show you that we can produce is called histogram. So to do a histogram, what we have to do is to highlight the data that we want to do the histogram for. So in this case, let's say account balance, right? So notice that account balance is numerical, it's numbers. So we can actually do a histogram for it, right? So the quick way of doing it is just highlight the column. And then what we do is we go to insert, and then we go to this icon. This icon look like a histogram. So all you have to do is to click the drop-down menu, and we choose histogram. And in the instant, the histogram is produced. So histogram is bar graph, where the bar graph are contiguous and they're together, and each one of these interval is called a class interval. So in this case, there are 7 class intervals. Now, the main purpose of a histogram is to look at the shape of the distribution to see whether the distribution is either skewed to right, in this case, or skewed to left if the histogram is the other way, or symmetric. And all actually care about in practice is whether the histogram look somewhat symmetric, so that we can assume the data is from a normal distribution. Now, notice that in this histogram, the class intervals have very odd class marks, right? So you can actually see that the numbers are not round and so on. So you can try to control it. Unfortunately, Excel would not allow you to do a good job. So let's try to see what we can do, right? So if we click on the interval and right click, and you say format axis, and we can go to the right hand side to see. So you can either say, I want to have more bins, more intervals. So you can click on it and you can change the number. So let's say we change it to 10. So now you have a little bit more detail of the histogram, but you can actually see that the class interval has the same problem. Now, on the other hand, you say, well, maybe I can actually change the class, the bin width. So if we change the numbers to say 10,000 in this case, and you can see that again, those numbers are not nice round number, which you actually want to see from a presentation perspective. So this quick tool is actually really quick. A couple of clicks you can actually get here. We give you a histogram that you can get a very quick sense of whether the distribution is symmetric or skewed to the right or skewed to the left. But if you want to use the histogram for presentation purposes in a report, then this feature probably is not most desirable. So instead, we can use another way of constructing a histogram. So let me just delete this graph for a while, and let's use the other way. Now, the other way of doing it is that we would like to control the class intervals. We want to make sure that all those class intervals are with nice round numbers. So how do we do that? Well, first of all, what we need to do is look at the range of data so that we know how many classes and what interval length that we should use. So in order for us to do that, what we should do is, first of all, take a look at the minimum of the data set. So from in this case is D1 to D87. Okay, so let's see whether we cover the whole data set. All right, so this function that we talked about before give you the minimum of this variable. And then we can also calculate the maximum, right? D2 to D87. Right, so the smallest number for this variable is around 4,000, and the largest one is about 77,000. So the best way probably is that we would start with 0 to 5,000 to 10,000 and so on. Or if you don't want to have that many interval, you can just have 0 to 10,000, 10,000 to 20,000. So this is what we want to do. Now, in order for us to enter that, we would create something called a bin range. Okay, so bin, that's the name that Excel want to use. And the first number is 0, and the second one is 10,000. So the length of the class interval is 10,000, and all we have to do is just now just drop it down, and we probably don't need, we only need to about 8,000 because 80,000 because the maximum number is 76,000. So this brain range should cover the entire data set. So now that we're ready, what we can do is then we can go to use the data analysis add-in. So remember the way that we add the data analysis add-in is to go to data and then data analysis add-in, and we can see all the programs that are available under the data analysis setting. So in this case, we're going to use the program called histogram. Okay, so we highlight histogram, we say okay, and again, this really uh, familiar input and output screen show up, right? So again, this screen asks us where the data is, so the input range, and what kind of output that we want to produce, and where do we put the output, right? So in our case, the input range would be D1 to D87, which is, as you can see, this is the data, D1 to 87. In this case, we want to include the name of the variable account balance. And on the other hand, we also have to tell the system where the bin range is. So we can, again, I want to show you the other way of entering the data is to highlight like this. And so you either can type in the range directly, or you can use the highlight to just to highlight the data. And notice that in both cases, we include the name of the variable. So labels in the first row, so we should check that. And so now this is how you specify the input to the program. And we can now deal with the output. In the output, we have to tell the system where to put the results and what kind of results that we want to produce. The best practice, as I said, is to put it into a new worksheet. And in this case, we also want a chart output. So we're going to check the chart output. So if we check the chart output, uh, the program, Excel program, would actually produce the frequency table associated with the histogram, as well as the histogram itself. Okay, so now that we've done everything, we say okay, and here we go. Okay, so as you can see, we have a table like this. This is like a frequency table, and the way that we read the frequency table is that 0 to 10,000. Let me just make it a little bit bigger for you by just zooming in. Right? So 0, of course, they have 0 frequency. 0 to 10,000 has 25 of them. So 10,000 means 0 between 0 and 10,000. And that's the only issue with Excel is it doesn't tell you exactly, and you need to know how to read it, right? On the other hand, 2 means that there are 2 observations between 70,000 to 80,000, and there's nothing over 80,000, okay? So all the frequency now is in a bar on this graph on the right-hand side. Okay, so let's just make it a little bit bigger, and we can just work with it. So if you are putting the graph together for presentation purposes, you can actually work on the various design elements of the graph, like the title, like the axis, the numbers, and the labels, and so on. But one thing that you should do, regardless, is to make sure that the bars are together. They should be contiguous, right? Because as you can see, the intervals are together, so the bars should be together. So this is not a histogram yet until you put the bar together and all the intervals are together. So in order for us to do that, all you have to do is to highlight the data, the bars, and then you go to the right-hand side and you click on this little icon here. And once you click on it, there's a couple of items that drop down, and one of the items is called get width. And gap width is basically the distance between the various bars. At this point in time, the default is 150%. So as you can see that there are actually quite a bit of gap. So what you have to do is to make it no gap, right? So if you put a number 0 there, or you can just use this control and pull it all the way to the left. and now here's the histogram. So from that point on, you can now work on the various design elements of the graph to beautify it. A couple of things that you may want to do right away is to get rid of the more. So to do that very simple, all you have to do is to highlight that and just delete, and immediately that particular interval disappear. Now, obviously, the numbers are all jumbo. If you make it bigger, the number become a little bit better. There's also another way of doing it is when you format the axis, you can actually look at how the numbers should be uh, produced. Okay, so here's the histogram, and that is a better histogram than the one that we show you in the first alternative. And the best way, of course, is that you have good control on the various class intervals, and the numbers come with nice round numbers. Now, again, even the zero interval, if you don't want it, you can actually just go and delete it off, and it would just disappear as well. Okay, so this is how we do a histogram. Now, a histogram is a older technique that has been around for quite a while and is pretty easy to understand. There are a number of newer techniques that's been developed in the 1970s, and I'm going to show you one of them. Okay, so let's go back to the data, the one sample. And again, I want to produce a graphical tool for this numerical variable called account balance. And one of the more modern way of representing this data is called a box plot, or box and whisker plot. And to do that, it's actually relatively simple in Excel as well. So all you have to do is to highlight the data and then just use the same graphical tools that we just showed you. Now, notice that this function is relatively new in Excel. Before, it takes quite a bit of time and effort to do a box plot by using a number of graphical tools in Excel and some tricks. Now, in the latest version of Excel, these things can be done very easily, right? So again, we highlight the data, we go to insert, we go to the same icon, and we're going to click the drop down. And the second option is called the, excuse me, the box and whisker plot. And all you have to do is click on it, and here we go. Okay, so let me just make it a little bit bigger, and we can talk a little bit about it. Now, Excel when we produce this, the default is that the box come with a color, and usually that's actually is not advisable, at least at the very beginning, because you actually want to see the detail, right? So in order to do that, all you have to do is go back up to the design panel, chart design panel, and you click on it, and you can now see a proper box and whisker plot. And this plot is developed by one of the more famous statisticians, Dr. Tukey, John Tukey, in his it was published in his book called Exploratory Data Analysis, EDA. Now, so what is a box plot? A box plot basically is a graphical representation that give you some detail of the data. This is the minimum of the data set. This box has the middle 50% of the data. So that means that this is Q1. So 25% of data is from here to here, and this is Q1, and this is the median, and this is Q3. Right? So the middle 50% of the data is in the box, and then the rest is the 25%. So notice that there are a number of circles there. They are what we call outliers, and the outliers are identified using certain method. So in this case, I believe is the 1.5 times IQL method. Now, some people would actually want to show the outliers because that's informative. Other people say, well, I don't really care about the outliers, so you would extend this arm all the way to here. Okay, if you extend the arm all the way here, it's called a modified box plot or just the box plot. If you have the outliers on the graph, it's called the box and whisker plot. So as you can see, we can use the graph to judge whether this distribution is skewed to the right or skewed to the left, right? So if you forget about the outliers, the data is actually not too bad. You can see that the box is pretty symmetric. Uh, these two arms are not too bad, but because of the fact that we have a number of outliers, I would consider the distribution to be skewed to the right. And what we have to do is we have to find ways of dealing with this outlier if you're doing data analysis. One of the things that you may want to do is also to highlight where the mean is, right? So this line represents the median. So you also want to see where the mean is so that you can give you a sense of whether the distribution is symmetric or skewed. So in order for us to do that, all you have to do is to highlight the box, and then you go again to same icon, like a histogram icon, you click it, and you drop down. So you can actually ask the system to give you the mean marker. So if you click on show mean marker on that side, you can see that now the mean is highlighted here. So now you can see that the mean is slightly bigger than the median. You can actually ask the system to show all your data set along this axis. So if you click on show inner points, they're all there, right? So you can actually get a little bit more sense about this part of the data, right? You can see that once you get out to about here, these data become kind of isolated from the rest of the data set. Usually you probably don't want to do that. The other thing that you want to do is to make sure that the quartile calculation is consistent, right? So there's two ways of calculating quartiles. In a previous video, we talked about that a bit. So the standard, the NIST standard, is excluding the median. So you can actually use exclusive median in the calculation. So, or if you don't want to, you can also change it to inclusive median, right? So in this particular case, it won't make a lot of difference, but in some cases, it does make some difference. So I would just use exclusive median as my default. The last thing you want to do also is to maybe highlight these points with the numbers so we can actually get a sense of what those numbers are. So in order to do that, you right click, you highlight the data set and you right click on it, and then you say, sorry, I didn't select the data properly, so let's just do the data again, and then right click on it. And you can now see that there is the menu item in this menu called Add Data Labels. So if you can click on it, you say Add Data Labels, and now you can see not only the outliers, the quartiles, and so on, but you can actually see the values, right? So in this case, you can see the minimum, the Q1, the quarter one, median Q3, and the maximum. So the 5-number summary, as we talk about, is all there. Now, the box plot, you can actually do it in practice vertically, or you can, if you do it manually, you can also do it horizontally. One of the best way of using box plot is for comparison purposes. Suppose you have 2 sample or 3 sample of numerical data, and you want to use a graphical tool to see whether there is a difference between the 3 sample data set or the 2 sample data set. Box plot turns out to be a very useful tool. So I'm going to show you how to do that as well, and it's actually really simple. Right? So I have another data set called 3 samples, and it's just a little data set that I generated, right? So sample 1, sample 2, and sample 3, and I want to compare them graphically. So how do I do that? Again, all I have to do is to highlight the data, and I go insert, go to the same icon, go to the same choice, and voila, right? Now you can see that the 3 data sets are represented by box plot side by side, right? So if you go to, again, if you go to click on the graph, and if you go to chart design, and you go to the second one so that you can remove the color, at least for now, so you can actually see the detail of the box, right? So you can actually see that, for example, in data set number 1, sample 1, you have an outlier, right? And otherwise the data is slightly skewed to the right. Uh, in sample number 2, the variability is a little bit bigger, right? So it's a little bit more spread out, but the median is a little bit lower than sample 1. And for the third one, also the first sample has the largest uh, variability, but the median is also the largest. So you can actually get a sense really quickly from the graphics. And so it's a very useful tool for us to compare several data sets at the same time. And there's Excel allow you to compare many data sets using these techniques. So it could be useful as well. So today we showed you how to use Excel graph to construct a histogram, and also the data analysis to do the same thing. And the choice is really on whether we want to have better control on the class intervals. We also show you how to use the same graphical tool to generate either a simple box plot or a multiple box plot, so that we can actually compare the various data sets. So now that once you get this, you can, again, using the same kind of approach to beautify the graph if you're using this for presentation purposes. So the various design element, again, the title, the y-axis, the x-axis, whether the details on the box plot, the background, the color, there are various things you can actually do to actually beautify the graph. So this is the end of the video. I hope that you enjoy it. We're going to show you other functions in Excel that is useful in elementary business statistics. Bye for now.